Moving on, we now have a segment, Making Breakthrough with IPU. The segment branches out to an in-conversation session with stellar panel of speakers on the topic, Chip on the Block Needs Smart Chip Innovation. The session will focus on the need for chips with advanced AI algorithm handling capabilities and on the India advantage. We have with us this afternoon Raja Manickam, CEO, OSAT Tata Electronics Limited. Raja is responsible to build ecosystem to productize and manufacture semiconductor products in India and globally. He specializes in semiconductor interconnect, test applications, and defined products. Along with him, we have Kumar Vemuri, Vice President, Architecture and Modeling, Imagination Technologies. Kumar has 2 decades of experience in senior engineering management and technology leadership. He has engineering management, architecture, and design know-how in highly parallel, multi-threaded, ultra-low power GPUs and AI accelerators. He has 9 patents to his name. The session will be moderated by Supria Dhanda, social entrepreneur in making. Supria is a social entrepreneur focused on the mission of creating a balanced world. She is a business leader with more than 25 years of corporate experience in leading technology companies as Western Digital, SanDisk, Alcatel-Lucent, and General Electric. It's a pleasure to have you all here with us this afternoon. Without further ado, over to you, Supria.
Thank you, Justin. I'm indeed excited to be here at the XperienceAI Summit 2022 hosted by NASSCOM. And thanks, Justin, for the introduction. We have our esteemed panelists, Kumar Vemuri and Raja Manickam. And I can't wait to look forward to the conversation. The conversation is going to talk about chip on the block needs smart chip innovation. Now, we all know, and you've heard this millions of times, we live in an era of smart world, comprising of smart devices connected to each other. And there are tons of millions of decisions being made. And how are these decisions being made? Because there is this extremely explosive emerging technology. I don't even know if you call it emerging. It's already here and have its play under the sun. Artificial intelligence, which is powering these decisions. It's looking at voluminous data, distilling insights and helping us convert data to information, to knowledge, and of course, smart decisions. It's powering, applications like transportation, the sectors, the retail, the banking, and of course, our world of connected homes. To unfold this conversation of what is new on the rise, that's called AI chip, we of course have our expert panelists, and I can't wait to get the conversation started. Kumar, Raja, welcome to the conversation.
Thank you.
Thank you.
Kumar, if that's okay with you, I would love to start with you to say, we are talking about many AI chips. And these AI chips are powering in different applications. It's almost like one AI chip in one different application. And they are, like I said, covering multiple sectors. And of course, there are many companies that are there which are investing in this. Talk to us a little bit about these AI chips that are on the rise and what is behind these applications.
Yeah, first of all, pleasure to be here, right, in the panel. The application space is a pretty huge topic. I don't think we can actually shrink it into this 20 minutes, but we'll try. So the applications you can broadly categorize into 2 areas. There are cloud-based applications which are typically running on data centers, and then you have applications which are on the edge. The reason why the story on the edge is becoming more and more interesting in this space is because, like you mentioned, the sensors are getting more and more sophisticated, which is to a lot of data getting generated, and a lot of these applications require algorithms to be processed at the origin of the data, where the data is produced. So these are extremely latency sensitive. Imagine a car, right? You don't want to send the data to the data center, and then data center comes back and tells you what to do, take a left or right. You want this processing to happen on the car, right? At the edge, space where the data is getting generated. So extremely latency sensitive, which is kind of making this whole space of edge-based processing extremely, extremely interesting. And the fact that the sensors are also getting more and more sophisticated, the quantum of data that is getting generated at the edge is also exploding. And because of that, the compute requirements all of a sudden shoot up significantly, right? A simple example would be you take one of the predominant network, a deep neural network. If you take that neural network called ResNet and deploy it at the native resolution at which it was initially coined, you will be in the range of 10 billion operations per image. But once you go towards an ultra HD resolution of image sensor, all of a sudden you're talking about north of 1 trillion operations per image. Right? So it's a significant jump, and you need that level of data and resolution from the sensors because you're talking about making a lot of decisions based on the data that is coming out of the sensors. And those decisions are possible only when you actually get this data at those high resolutions, right? So compute requirements are going up significantly. That's at a very high level, right? Now, once you start going down further, you will notice that this whole space of AI actually is finding itself, finding its way into multiple verticals. Everybody talks about automotive; it doesn't require any introduction. But if you're talking about areas like agri-tech, where AI is finding its way, right? You have this tractor, and you retrofit the tractor with a bunch of cameras and a compute element sitting on it, and the tractor moves, and the cameras identify where to spray a pesticide. And that is based on the situation of the plant and the leaf, etc. Right? And then the economics comes in, as in how fast the tractor moves is important for the overall battery life and the commercial aspect of it. So once we start talking about speeding up the tractor when we are spraying pesticides, again, right, we're talking about expansion of the compute power again. So there are these interesting areas that are emerging, which probably nobody would have thought of, right, 10, 15 years ago. And so that's another example. Industrial applications are another interesting ones, right? And manufacturing. Healthcare is another very interesting area, which is very relevant to India also, by the way. So different verticals have emerged, right, where AI can have significant advantage. Now, the interesting thing, again, if you now go down further, what we'll notice is every vertical has their own set of platform requirements. As in, let's talk about industrial application, right? You don't need to be probably running the chip on a battery. So the whole system is probably plugged into a power socket, so you're not so power sensitive. But whereas when you start looking at something like automotive, extremely power sensitive because you're running on battery, so power requirements are very stringent there. So every vertical has their own set of platform and system requirements, right? So it's extremely, extremely fragmented from a solution space also. And then on top of it, now if we dig down further, what we'll notice is the algorithms that are running on these platforms are also ever changing, right? Every month there is a new algorithm that comes up on the horizon, and of course, that's good because a lot of the compute requirements, the algorithm developers are actually trying to bring down the compute requirements of a lot of these algorithms. That's a positive thing, right? So there is innovation that's coming in and kicking in multiple dimensions in this space, and that's what makes this space extremely, extremely interesting because given the number of verticals and the kind of requirements that each vertical has, the kind of applications and use cases, this space is definitely an area where a solution will not be, we cannot really imagine a solution that fits all. You'll definitely need multiple solutions from a hardware standpoint. And this entire stack that I just explained, the maximum value is going to be derived by the guys at the bottom, which is basically the hardware, system vendors, not just the chip designers, but we're also talking about the integrators, etc. Right? So that's where the most commercial value is going to be derived. So it's a very interesting time in general for the semiconductor industry because it's pretty much opened up a new challenge for the industry to go solve. I'll leave it at that.
Awesome. That was a brilliant picture you painted, Kumar, of the entire stack, various applications, and how there is definitely going to be an AI chip for a different application, considering the entire ecosystem that it powers and it enables is so very different. Talking about one specific application in manufacturing, Raja, may I invite you to come in and talk to us about that?
Thank you. Just to, where Kumar left, right? See, and especially this is a NASSCOM event, right? So you have, software and the chip, right? So we being, from the chip guys, right? So traditionally it has been that, you basically have a chip which has all these functions, and then your software, you kind of just run it on top of that, right? Now I think on this AI, right, there is going to be all kind of algorithms coming out specifically to address a particular solution, right? Whether what is required for the tractor versus what is required for sensing sound and making decisions based on sound and so on, right? So there's going to be multiple, and this is where I think it's not going to be it's like a China wall between a chip and the software, right? There's a lot of things that you need to do which will optimize the chip, right, in order to run that software. So what I feel is typically, right, the chip designers have very little say on the software side, and typical and vice versa, right? In a typical chip flow, what you notice is, we'll come out with the chip, and then it'll go onto the bench to do verification, right? And then you'll find that, the software guys will always be complaining, hey, this is not what I thought it should be, right? So I think there's a lot more collaboration that needs to happen because, the real estate, right? So imagine if you have a chip, any solution has to, probably in the next 5 to 10 years, is going to have an AI aspect to it. And what is AI, right? It's basically a learning, right? So you're going to create a learning in the chip, right? Now, how complex it is or how simple it is going to be defined by, what kind of software needs to run on this. So I think there's going to be a lot more interaction in that sense, right? So, chip, for some of you may not know, the cost of chip is basically the real estate, right? You can relate to a real estate company and a chip very, it's analogous, right? They're very similar. The bigger the real estate, the more expensive it is, right? So I think if you're able to create more and more customized solutions, right, with the software, I think that's where you're going to win. So certainly with our strength in the software, right, is going to help as you get to understand more and more of how the chip is made or how it's defined and so on. Coming back to manufacturing, right, I think it's going to touch AI is going to touch almost everything, and it's going to start with any AI solution needs it's a technology solution that needs to get added to let's say a current solution or a future solution. And what to me, when you say technology, is two things, right? It will be the chip, which is a hardware piece of it, and then there will be the software that runs on it. So typically, again, right, in a chip company, we focus on trying to make the chip with particular node and so on, right? So we really don't focus so much about the end application itself. I mean, we do, but a lot of times, right, it is a general kind of approach. If you ask the chip guys, right, they have very little knowledge about the the final application. You may have it at the definition of the chip, but as it goes through the process, right, we lose it. Because I being a test engineer, right, I'm at the bottom of the totem pole, and by the time we get it right, we have no idea what this chip is for. We just run some vectors and make sure that the power and the power budgets are there, and where this swings up and down, the thresholds and stuff like that is what typically we don't even know what the application is. So I think with this AI, there's a lot more you can define at the end product and then take it back, right? Rather than the way that we used to do, where there's an architecture in the front, and the final solution may or may not fit, and so you can cut down on the time to market. So what I call SLT, which is a system level test. A system level test is really the application test that happens, that before the chip gets to the market. And so that SLT itself could have a lot of AI implementation. And so all you need to do, imagine, is every chip or every solution that comes out has a little AI engine in there, right? And we can do it now because of the real estate available that you can, right? Maybe it's on the package, or maybe it's a separate die, or integrated into a solution itself. So I believe the first people who will take a big advantage of this will be the chip manufacturers themselves.
Awesome. Thanks, Raja. It's brilliant. We have the entire application and the entire world of agriculture, the tractor moving and the speed and at which, the inputs are being given. I think that was fascinating. And, the visualization just came through. And now with the ways, bottom of the totem pole, but of course, it's so exciting. So I think we have an opportunity here in AI chip where we are closer to the application. And Kumar, back to you, from AI hardware to the application, what are some of and you spoke about the compute requirement, you spoke about on the edge, how it is that we need to power in. We don't have the time for data to travel back and forth. And therefore, there's a lot of decision processing that needs to happen and decision needs to be taken. Talk to us a little bit about the traditional chip. How is AI chip different from that? What are some of the architecture level changes that are now being envisaged? And therefore, how fascinating it is for all of those who are attending this, experience the AI summit and, let them experience this new world that's evolving.
I think it would be good to just take a step back, right? Some 10 years back, when the chip on the block, which could offer so much of compute, was not the CPU, but the GPU, right? So ton of compute out there, and folks started saying, hey, this ton of compute, why don't we just use it not just for 3D graphics, but also for AI applications. So it definitely helped in establishing the idea of AI and the promise of AI in terms of what it can solve, right, in real life situations and all. But very soon people started realizing that, hey, this GPU-like architecture is probably not ideal for these kind of applications. And I'll take a simple example there. So if you look at the GPU, the ton of compute that a GPU is packing is typically in floating point, right? Which is very heavy in terms of the real estate which Raja was alluding to, right? Makes the chip very heavy, which kind of translates, which immediately translates the cost the customer has to pay. And it also has its implications on power and other aspects. But if you look at the algorithms in the space of AI, etc., they don't require floating point. Generally, they don't require floating point compute. So they can actually go to a lower position, right? And once you start going to these lower positions, it means that now you can actually pack more compute in the same real estate, right? So that's just one example of how the applications are driving new architectures in this space, right? So all of a sudden, people start realizing that, hey, maybe GPU is not the right architecture for this, and we need something else here. And then over the last 7-8 years, there are several startups that come up, right, in this space, trying to solve this exact same problem. So there is significant opportunity here for players across. And the big opportunity that is also emerging here is that the big ones, right, Intels and AMDs and NVIDIAs, have predominantly played on the extremely programmable space so far. But the fact that there is a spectrum of needs here, it kind of opens up opportunities for new players to come in and bring up something very interesting. Now, as Raja pointed out, hardware is just one part of the story. There is a software element which sits on top of it, which is extremely, extremely important. And that's where that also is one of the key considerations that goes into any hardware architecture. Because at the end of the day, you don't want to put your customer in a situation where he's not able to port his software stack from a previous hardware to a new hardware. So thank God there are some frameworks which have emerged, which sit between the applications and the hardware. So all the hardware architectures will have to keep this right in the right, one of the threads that, hey, look, we have to export a programming model which can support these frameworks, which will allow the customers to port their applications across multiple hardware platforms.
Awesome. Kumar, it's lovely the way you talk and the way you paint the picture. And my gist of this is that, yes, this is just beginning. It's an explosive, potential, which is why I think the session is rightly titled to say innovation. And I think there is so much waiting yet to be explored, problems yet to be solved. You spoke about a beautiful word called opportunity, which brings me to my, next conversation that I'd like to steer to. We have India as a powerhouse of talent. Raja, these are your words. You had called it that, so I'm just stealing it right now online. You called it India as a powerhouse of talent. We have so many talented engineers, and there is this entire startup world, which is also kind of, we are making our inroads into understanding new problems, coming up with new solutions. So talk to us about, Kumar, I'll stay with you, and then Raja, same question, I'll flow to you. So Kumar, the opportunity that India has, we've always had, at the cusp of these to say, here is this new wave. India has the opportunity like any other region. And what do we need to do to ride the wave?
I like the phrase powerhouse of talent, right? India semiconductor space has been around since what, early 80s in India. So, and most of the major players, right, that we generally talk about in terms of AMDs, all of them have big shops here in India for decades now. So there is a lot of skill set, a lot of expertise that we have at the early stages of the entire chip design. Like Raja mentioned, right, there are multiple stages that go in when you're bringing up a chip. So all the way from architecture to micro architecture, design, verification. I think we have enough skill set and talent in India across all these stages. Given that, I think there are, from an opportunity standpoint, the space, like I said, India has its own set of unique problems, right? Traffic, big problem. You guys living in Bangalore will vouch for it.
We do.
Right. So I'm sure, other cities are no different, right? I'm just taking an example here, right? Traffic, etc., the two-wheelers, right? So India has its own set of unique set of problems and challenges, which brings up the ecosystem into play now, right? We're talking about OEMs, etc. They should start contributing into the space, and then we are talking about the next layer of the stack where we are saying, hey, new algorithms should emerge, right, for these kind of specific pointed applications. Then we are talking about universities and the research that goes on in these universities, right? So there's a significant opportunity for them to actually now collaborate with these other players in the system, and then do something very pointed towards solving these problems. And then at the bottom you have this powerhouse of talent when it comes to building the chip, right, designing a chip. And even the design of the chip, we often start thinking about actually designing the core inside, different cores inside the chip. There's one more layer above it where you're talking about an integrated, like where you're saying, hey, I'm going to purchase these integrated, intellectual properties or IPs from different companies, integrate them and build a chip or a solution for a given vertical or market. So you can actually create solutions that way. So there's an opportunity there also. And then, if you go one level further down, you're now talking about, architecting new compute engines. So there are opportunities lying at different layers of the entire AI stack. Now, for all these things to materialize, I think we as a country have to be brave, jump into it. All the ecosystem elements have to come together. And the biggest element there is the investment. Right? Investors also, we have to start seeing investment in this space. It's understandable that it is, so the space is actually capital intensive and the development cycles are longish, which are slightly alien to the investors here. But that's one area I think if we start seeing more investments, you will start seeing more engineers taking risks, coming out, trying to do these things, right? And then the OEMs, right, also kind of jump into the entire mix. Then all of a sudden you'll see that the ecosystem will actually start moving, right, India-centric. And the best part here is that, like I said, the solution space is extremely fragmented. And in spite of that, the scale of installations, we're talking about tens of billions of units of shipment here, right, worldwide. So you're actually not, while you're creating this solution for India, there's nothing preventing you from playing worldwide, right? So you have an opportunity to actually start here and then expand your reach outside. So the scale is huge. There is room for multiple players.
Mm-hmm.
So it's a great time for us as a country to jump into this space.
Awesome. I like that. Raja, while we can talk about the India opportunity and the advantage, could you focus more on, in the same question as to what India can do different, what engineering leaders, the industry can do different? Of course, investors will listen in, once I'm sure they tune into the session.
So I think, great opportunity, right? So the way I would just kind of flip it upside down. Most of the chip companies, right, especially the big digital guys, right, whether it's Intel or AMD or NVIDIA or Broadcom, they have a lot more software engineers than actually chip designers now, right? So imagine, right, they're becoming more and more like a software company, right? So, it's always software driven, and, Broadcom has taken it to a next level where they're actually acquiring software companies now. right? So imagine, right? I mean, we are a powerhouse in software. More on the at a higher level, more on the application side and all that. So what I think the opportunity is for these software companies to tread into the hardware and the chip side of things, right? It's good business, right? So, and I think they have a real big advantage, right? From a chip company or a system company to become a software company, I think it's a lot more challenging than for, vice versa. Right? So I think there is a huge opportunity for software guys. And so you don't draw a line between, I'm a software company, so I don't need to, invest in, the system, the platform and so on. I think because of the way the solutions are going to come, it's going to be a lot more customized, right? So the software, the hardware will play a very, very critical role in how the software is being used. So I would solidly encourage, NASSCOM companies and other, software guys to think seriously about this. And certainly they have the money to invest, to help out, people like Kumar, who's got this, the greatest ideas, right?
Awesome.
And the second part is on the talent, right? Again, right, as a chip, services company that I was in, it was very difficult to find good talent, in the chip design side of things, right? A lot of people will opt for, more like an IT or even software, right? So for some reason, right, we feel that software is a lot easier, or maybe there's a lot more opportunities and so forth, right? So I think at an academic level, right, bring in AI is part of the course, right? I mean, just like you would have computer science, right? When I first went to college, my third year is when computer science actually started, right? There was no computer science before that. So
I won't ask which year that was.
no, you don't know. A very long time ago. Okay.
We'll leave it at that.
Yeah. So I think, we'll, what my thought is, bring in AI as part of the, curriculum, and teach them more from, not just on the, the software, algorithms on, but how do you take an algorithm and make it into a chip, right? Really, a chip is basically nothing else but a mathematical, derivation, right, of software, an algorithm, right? That's all you do. So I think, those are two real big opportunities. And we have huge amount of, real life applications in India, right? So India could be a, very good beta site for an alpha site, beta site, right? So it could be for a global solution. So
Awesome.
great opportunities, I think.
Raja, you've already captured the closing comment in terms of, if I may say that, to say that, India has it's a powerhouse of talent, but more on the software side. And I think one should just come forward and think there's a huge lesson for institutes, academia too. We're always talking about academia industry collaboration, how the talent needs to be really on the edge and usable the moment they graduate. And I think you said that that's a direction. Kumar, may I invite you for a few closing comments to say, we're almost at the top of the hour. It is shocking how time flies. If there's some way somebody can innovate how to stop that, pause that. But Kumar, a little bit closing comment on saying future of AI chip. Is there anything that is there in your mind, but that's unknown and you see that's going to be kind of, coming into the market?
That's a tricky question, right? Things that are unknown. So, but then I get the drift, right? There are several areas. The whole space of AI is pretty nascent at this point in time. It's very early, I would say, right? And it's going to emerge as we go along. So I would say, it's out there, and again, right, plenty of opportunity there. You will not see standards in this space. Specifications and standards that the typical, chip designers are used to, which makes the problem even more interesting. So it's an unknown space, moving target all the time. So yeah, it's interesting. That's what makes it interesting and challenging, right?
Awesome. I love the excitement. So I've thoroughly enjoyed. Raja, Kumar, thank you so much for a session. It's like I said, it's amazing how time flies. I hope the viewers enjoy it. We were talking about chip on the block needs smart chip innovation. When we are talking about chip on the block from the world of standards, measurements, a pretty much broadly known spectrum, to completely getting into an explosive unknown territory where even Kumar refused to comment to say unknown is unknown. And I think you engineers out there, you leaders out there have a huge opportunity opportunity. And as always, India has this great opportunity to be the alpha, the beta side and kind of be the global solution provider. I always get personally excited when I raise the national flag and say, India, this is our moment to shine yet again, and I'm sure we'll make most use of it. Well, thank you so much, Raja Kumar, for your valuable time and for unfolding this beautiful, beautiful unexplored world of smart chip innovation.
It was a pleasure being in the conversation here. Yeah.
Thank you very much indeed for that candid and insightful session, Supria, Kumar, and Raja.